Welcome to Alexander Karnes and the Magic Box. I have owned this box for many years, and now there is an ideal opportunity to find out more about it. Alex knows what it is and explains in detail how it works. Over now to the live audio in the workshop. Alex, what are you looking at?
Treasure. So this here is really a basic literacy class for anyone who works with steam. If you don't know what this is, you need to, and that's why we're making this video.
It looks very complicated, Alex, and I'm not being naive. It looks very complicated, Alex. So
Right.
What is it?
So this is called a steam indicator. It's actually very simple. It's one of the simplest things there is, but this is and should be as important to anyone who works with steam, and I'll explain why. So this apparatus draws a graph. It's this simple. We connect this end to the indicator cock on the steam engine. On the side of large steam engines, really any steam engine, you'll see these things that look like they're for cylinder cocks that are unused. A lot of people who don't know any better use them for cylinder cocks. Not to be confused with the timing ports on a piston valve engine, but on a big engine like a Corliss, like on a mill engine or something, you see on the side of the cylinder, you see these two valves at either end which come to a pipe that goes to the middle with a single valve, kind of a complex four-way valve, which is this, that goes on top, right? So this is always there. The really nice indicator sets have them in a box. This is for a compound engine because there's two indicators, one for the high and one for the low pressure cylinder, and the springs to suit. I'll come back to that in a minute. Here, this is on your engine all the time, or in your box if you're a very conscientious engineer, when you want to indicate your engine. So you'd screw the indicator on to the indicator cock, and you'd screw this down, and of course each thread is proprietary for the manufacturer, because if one manufacturer furnished you your indicators and your gauges and whatnot, they'd only want you using their indicator, so the threads on these are proprietary. You can even see them in the box where they screw in. You select with the valves either one side of the cylinder or the other, either with the valves at the ends or this four-way valve underneath, which is either one side of the cylinder or the other side shut off or drain to atmosphere. And then this is just the valve that makes the indicator communicate with that. Of course, it's stuck. This is a very sticky set. I'm going to have to work on this. But in any case, the pressure in the cylinder drives a piston in here against a changeable spring. The pressure in pushing on the piston moves this stylus up and down, which will have a pencil lead in it, or an ink pot, but usually a pencil lead. So that is the y-axis of your graph. The other axis of the graph, of course, is the x-axis, the horizontal, and you get that by turning the drum. You connect this string to the engine crosshead. And if the indicator only has, let's say what this is, about 3.5, 4 inches of travel, you attach what's called a pantograph to the engine crosshead, which is like a big lazy tongs to reduce the motion from, if it's like a 36-inch stroke engine, to a 4-inch stroke or whatever. The pantograph will have all those numbers on it for you. But basically, the graph produced by this instrument is a rectangle card. You put it over this. In fact, in here, we have some. Here are some of the cards.
A Crosby steam engine indicator diagram. Crosby Steam Gauge and Valve Company. Made in England. Please explain why there's no U in gauge.
I can't explain it, Keith. It's an Americanism. I'm sure some worldly wise historian out there could explain it, but I can't.
Alex is now going to fit this piece of cardboard, or thin card or paper, around this drum. All very technical.
Yeah, but it's nice. So here's the new card fitted to the drum. This is a blank card. Now, unfortunately, I can't have this draw card for you because we don't have a pencil lead in this. However, if you put this on the steam engine and you select one side of the cylinder, only one at a time. As that engine is running, this is always going back and forth because this is connected to the crosshead. It's always going back and forth. What you have the ability to do is, it's very sticky right now. This thing needs a whole bunch of oil, but...
WD?
That's not an oil.
Well, I know, but it's good for unsticking things.
Yeah, they're very, very... Oh, no, I got it. Okay, so, you see how this pivots?
Yeah.
That gives you the ability to lift the pencil off the graph at any time you want. So really what you do first, you need to establish what's called an atmosphere line, the zero, right? So this thing is always going. That engine is going along, the crosshead's going back and forth, and so is the drum. So as that's going, you touch this down with all the valves to this closed, and you draw the flat line, which is our atmosphere, 0 psi. Then you lift it off. Then you open the valve and get this in communication with the side of the cylinder you desire to indicate. This will start bouncing up and down with the steam pressure on that side of the cylinder. You touch it down again for 1 or 2 revolutions and lift it right off. Then you disconnect the indicator and you pull the card off. Okay? And I'll show you what you will see and what you want to see. This is kind of a holy shape for steam engineers. And this is what we call the ideal indicator card. All right, and this is because this is the card of a steam engine that is highly tuned with nothing wrong with it. Okay, and you can see I've drawn here, this is actually the circular diagram of the crank. We have front dead center here and back dead center here. We assume it's a horizontal engine. And you see as we go around, as the engine turns clockwise in this case, we get a 10-degree of lead. The admission opens 10 degrees before the center. We cut it off about 20% of the way through. Then it goes and we expand the steam the whole way. We open the exhaust, we let it all out, and we keep it open until about 7/8 through, and we close it for that recompression. So the points on the circle of valve events, this is what we talk about when we talk about valve events, to demystify it for you. I've duplicated on the indicator card. Here's our admission valve open, which begins the process. We're at the highest possible pressure. If it's an efficient engine and piping system, this is boiler pressure. Then we cut off the admission steam, is where the term cut off comes from. Then we get all that useful energy out of that little bit of high pressure steam by expansion. At the end, we open the exhaust valve, we let the steam out, and it returns back the other way. This is one side of the cylinder. We shut the exhaust here for recompression for an efficiency gain, and also, more importantly, to protect our crank pin and our crosshead wrist pin from all the inertia of the main rod and the engine crank and the crosshead itself and everything from going through the cylinder head and breaking the crank pin. It's actually very important on any engine that goes fast or that has heavy pieces. And then we go up the recompression curve with the exhaust valve shut, and we restart our cycle. Now, the great thing about this is the horsepower of the engine, the total horsepower of the engine, is all the area inside this this loop. That's so a horsepower, you need what we call the mean effective pressure, which is that. The area and length of the stroke, the area of the piston and length of the stroke, and the number of strokes per minute, which of course is the engine RPM. So to get our mean effective pressure, we literally take this diagram, we take a little tiny simple instrument called a planimeter, which unfortunately I don't have, but it's so simple. It's an instrument where you have a fixed point and a moving point. You fix the point with one hand, you move the point with the other, and the device counts the inside area of any loop you trace. It's that simple. So what you do is you change this kind of complicated shape into a rectangle. And that top line of the rectangle, because remember up and down on the graph is pressure, the top line of the rectangle is what we call the mean effective pressure. So that is the first step of your horsepower calculation. But it gets even better than that. Because if the diagram ends up with funny shapes that you don't like, you can tell exactly what's wrong with your steam engine. For instance, if you have a slanted top to that admission line here before you cut off, you know that the steam is having trouble getting from the valve chest into the cylinder. You have a restrictive port. If you see this drop off before the end, you know, oh, the exhaust is opening way too early and you're releasing the energy of live unexpanded steam up the chimney. And on most locomotives, especially old ones, like 1930s, because I'm not talking old, they have this problem, and you hear this up the chimney of this live steam being wasted, which is partly why I like compound engines with modern valves. And then if you have something like this, if you see a slant upward on your exhaust stroke, kind of an even slant. Remember I told you before, you draw the zero line underneath first. If you're above this the whole way and you have a slant up on your exhaust, you have a constrictive exhaust valve or piping or nozzle. If you're on a locomotive, the nozzle in your smoke box is restricting you, is causing back pressure. It's horrible. It's a horsepower parasite because you see, remember I told you the shaded area in here is part of that horsepower equation. If this loop shrinks and the area inside it shrinks, your less power is going to the wheels. And you see, I've also done something here to illustrate this to you better. These are called Zoyner diagrams, right? And these show you port opening per crank position. So this is an old-fashioned engine with a slide valve and like a Stephenson's valve gear or something. And you see the valve opens very slowly, and it's only fully open in the middle, and then it closes very slowly. And here we've got that early lead. It begins to open before the dead center. It closes, like I've shown you, about 20%. And then this is the exhaust valve opening. It's the same kind of problem, like a crescent moon. And you see, on an old-fashioned engine, inefficient port opening, because you get throttling at the portion where the valve isn't all the way open. You get wire drawing, which actually erodes the metal away. And then, because you have a pressure drop across the port, that's expansion occurring across the port that is not occurring in the cylinder, in this part, meaning it's energy wasted. Even though the steam isn't leaving the engine, you're wasting energy because there's a pressure drop that is not driving the piston. Efficient port openings on modern engines that I like the French locomotives and things, where we have the long travel piston valves like what Nigel Day and David Wardale work with. The valve goes way past the port, it opens fully, and it stays fully open, whether admission or exhaust, before snapping closed, so there's none of this throttling going on. So all of these things and more come from the information that the steam indicator gives to you. It's that simple. And if anyone out there wants to try one, but they don't have access to a big, fat, full-size steam engine, you don't need one. Because remember something, pressure is pressure, right? So if you have a little model engine, even a Stewart score, you can connect this to one end of the cylinder. And this pen, you may not think so, but this is a very sensitive instrument. In fact, such indicators are even used to indicate internal combustion engines like diesels that run at 1,000 RPM. This is responsive enough. If you have a little Stewart score or a 10V running at 1,000 RPM, you can actually draw a card with this, provided you connect this to the crosshead good enough, and there's not like slop in the string, or you're not banging the graph chart. You can actually indicate model steam engines with this.
A question for you, when does this date from?
This here, well, let's see. The latest patent date on this is 1895, so it can't be from before then, but it could be from right then, because look at it. It's beautiful, it's ornate, it has blued steel screws and arms, and it's nickel plated. And the trademark, the Crosby shield, is nice and sharp with very nice, well-defined letters. It's not ugly the way it would be if it was from 1920 or 1930. So I think this could be from the heyday, the 1800s.
I can't remember where I got it from. I think someone gave it to me, and I looked at it and thought, well, it's such a nice-looking thing.
It's treasure.
Yeah.
Oh, and there's another little tidbit for you. Very, very important to know. In here, there are several rulers. And you'll notice that all the rulers correspond exactly to the height of the drum. But you see, they're not ruled in distances, they're ruled in pounds per square inch. And every ruler is different. Like, for instance, this one is 0 to 350 pounds per square inch. This one here is only -10 psi in vacuum to 50. And the reason for that is, this indicator is made to indicate any steam engine you throw at it, whether it's an old James Watt beam engine from the 1790s that only runs with a boiler at 5 or 4 or 2 psi, or a modern engine running at 300 psi. And the way you tune the indicator to these engines is, you see these different springs in the box. You take the springs in and out of the piston cylinder. This is the spring sets a return pressure. So if you change the spring from this very, very tight one that I can barely squeeze, which is probably the 0 to 300 spring, to one of the springs with a very thin wire, which is very easy for me to compress, that's probably the 0 to 40 spring. So depending on what engine you put this on, or if it's a compound or a triple engine and you have different pressures, different cylinders expected, you change your spring to suit. It's that simple.
Incredible. I never realised that. I don't think I'd want to mess about with a small model engine, because for what I do, I can use my ears. But I do get the point when it's serious money's at stake with,
yeah,
you know,
the price of coal, the price of water,
the price of air conditioning.
Yeah. And I'll just tell you right now, anyone out there watching this, if you have a Stewart Victoria or a Twin Victoria or a 5A or something like that, if you put that indicator on and you put a little load against the engine, whether it's a brake shoe or a dynamo or a pencil sharpener, you will successfully calculate the horsepower of your little engine if you know how to hook this up.
It is simple, yet extremely complicated,
Yeah.
but simple at the same time.
Yeah, and nuanced. It's all nuanced. And I've known people who couldn't figure out what this was for some reason, despite looking at it for 3 hours. But it's just so simple, and this is a fundamental device. These devices are as old as the steam engine itself. They were created in the Watt and Newcomen era by people like McNaught and Watt and others. And they've been around forever, and you need to know what it is and how to use it. Before you even touch a steam engine, you should know all about what this is and how to use it.
Looking at it from here, and I hate to say this because it's sacrilege, but wouldn't it make a really good candelabra?
So we'll have to shut off the camera. Keith's about to be missing both eyes and all his fingers.
So it's a piece of beauty. It's a let me look at it. That's a very beautiful thing.
It is.
You know, the way it's machined. Have we lost something along the way? This is obviously 1800 CNC, isn't it?
Yeah, and you can see also there's a serial number.
Yeah.
What's that one? This one here is
9598.
Yeah, these are early then. They're very early. I'd expect those to be 5-digit numbers at least. So those are quite early.
That's beautiful.
Yeah.
I don't think I'll ever use it. So as I said to you earlier, if you can get it back to the States, it's all yours.
Thank you, Keith. I will treasure it and use it well.
This is a slightly longer video than normal because the functionality of this wonderful box of tricks really did take some explaining, and this wasn't the fault of Alex. It's a very complicated yet simple device. Anyway, it's now back in the box, and very shortly it will be winging its way across the Atlantic to Alex when he gets home. That's it for now. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.